Learn together, pass together, grow together. So, today we learn describing network communication with models. So, here is something that blows most people's mind the first time they really get it. Every time you click a button in a browser, load a web page, or stream a video, there is their entire journey happening underneath. Layers and layers of packaging, addressing, and conversions, all in milliseconds. And once you actually see it, networking starts to make sense in a way it never did before. That's what we are doing today. We are walking through the OSI model not as a list of 7 things to memorize, but as a living, breathing process. And we are using a real example, pulling a matcha recipe from an example server central repository to make it stick. Right? Let's go. One click, 7 layers. Someone walks up to the back office computer at example server, open a browser and click the button that says matcha. Simple enough. But here is what actually happens. That click puts in the application layer. Layer 7. Any network aware application lives here. Chrome, Firefox, Edge, they all count. Soldier doesn't not. Doesn't. The moment you are talking to another device, you are in layer 7. As the request moves down to the presentation layer, the browser format it in a language the server understands. Let's say this is how we ask for things. And here is the keyword, which is encapsulation. It is the process of wrapping your data with a little header at each layer as it travels down to the stack. The data picks up the new jacket at every floor on its way out the building. The next layer is session layer, which handles bookkeeping. Keeping your browser session separates from Spotify, your email, and everything else running on that machine simultaneously. Port numbers, coming up in a second, live in their neighborhood, which is transport layer, where things get real. The transport layer is where the application makes a choice. TCP, which is reliable, or UDP, which is unreliable. And before you say, obviously picks reliable. Hands on. Reliable means the receiving side has to acknowledge every packet it gets. That's great for web browsing, not great for video streaming. If you are watching a live stream and a packet drops, you don't want to network to pause everything and go back for it. You are already 5 seconds past that moment. So streaming application uses UDP, which is user datagram brawl, which is just send it. We deal with the gaps. Okay. So also at this layer, port numbers. There are 65,536 of them. When your browser sends that matcha request, it gets assigned a random high numbered source port, say like 55,192, and it targets a destination port of 443, which is HTTPS, one of the well-known ports under 1024. When the server responds, it flips it. Its source port, which become 443, and destination port become 55,192. That's how your computer knows the response goes to Chrome and not Spotify. One network card, thousand of packets per second, and port numbers are sorting all of it. That's genuinely cool. Okay, now the last three layer, which is network, data link, and physical, are the final stretch. The network layer adds IP addresses, source or destination. This is the end-to-end address. Think of it like your final destination city on a flight itinerary. You know where you are going overall, but you are still going to make stops. Those stops are handled by the data link layer, which uses MAC addresses. MAC addresses are hop to hop. They change at every router along the way. The IP address stays constant from source to destination, but the MAC address only gets you to the next device. Every router strips the old MAC header off and slaps on a new one for the next leg of the trip. Traceroute makes this visible. You can literally watch your packet hop from router to router across the internet. And finally, the physical layer takes all that beautifully encapsulated data and convert it to electrical signals on a copper cable, pluses of lights on fiber or radio waves over Wi-Fi. It's just ones and zeros flying across the wire. The whole picture is that. So there it is. one matcha button click, 7 layer of packaging, addressing and signaling, and on the other hand, the central servers unpacked it in verse order and send the recipe back to the same way. Like it goes like this, and then when server wants to read it, it goes like down to up. Okay, I know you might be feeling like you only half got at that. That's fine, that's actually perfect, because we are going to keep building on this IP addresses, routing and switching, and every time we do, this model is going to click a little more. Come back to this one, I promise you will.